welcome to DPS 2020. We are here to talk about SQL Server Encryption Unplugged. This is an in-depth presentation on SQL Server encryption. My name is Ben Miller. I have been an MVP for almost 11 years, and I'm SQL Certified Master. Let's get started. This is the Yay Me slide. The only thing you have to worry about on the bottom is the DBA duck. I'm everywhere. I'm DBA duck, LinkedIn, Facebook, Twitter, I believe even Instagram. And my email address is there on the screen. You can take that and feel free to email me if you have questions afterwards, or if you have any things that you want to know about PowerShell or whatever for DBA. And my website is on the bottom, so you can go there as well. I'm also DBA duck on GitHub, so the presentations and the slides or the demos will be there as well. So let's move on. This is the agenda for our session today. It will cover the encryption hierarchy. That is the underlying foundation of using encryption in SQL Server. Then we'll go over transparent data encryption, and there will be two flavors, one with traditional and one with Azure Key Vault, and that will become important. Then we'll talk about cell encryption and how that differs from the others. And then we'll talk about always encrypted, where you can encrypt columns with keys and column master keys and column encryption keys. And then we'll finish with backup encryption. And then there will be a lot of demo. So let's go forward with this. Encryption hierarchy, we're going to talk about master keys and certificates and symmetric keys and all the things that make up the encryption hierarchy as a foundation of encrypting databases or keys. So this is the one that you'll find out on the documentation page. It is pretty intricate, and it basically starts with the Windows operating system and DPAPI, and then moves down the level to the service master key, and then all the way down to the encrypted data that sits on the disk. The important part here is that it flows through each piece, and you cannot miss a piece or you will not instantiate your hierarchy. In this case, the bottom is your data, and the one level up from that, the symmetric key, is actually the database encryption key. So let's talk about that in a little bit simpler way. Another way to look at it is you have to have a master key in the master database. You have to have a server certificate. You have the database encryption key in your database, and then you have your database. That is what we're going to be talking about. Here's how it works. The Windows operating system will protect the service master key, which gets created upon install and startup. So there will be a service master key that gets loaded by the SQL Server engine, and this is encrypted by the OS. When you get into the engine, you'll have the database master key, which will sit in the master database. That database key is important in establishing the hierarchy at the start of SQL Server. So basically each level that you see in this hierarchy is encrypted by the one above it. So the service master key is encrypted by the operating system. The database master key, or the server in master, is encrypted by the service master key. The certificate gets stored in the master database, and it is encrypted by the database master key in master. And then the user database encryption key will get encrypted by the certificate, or as we'll refer to it from here on out as the server certificate, because that certificate is stored in the master database. Let's talk about TDE and how it works. The master key, the server certificate, the database encryption key, all illustrated in the database hierarchy of encryption. First, TDE is really all about encrypting your data at rest. The data that sits on the disk in the files is encrypted. The data, the log, all of that stuff is encrypted once this is enabled. The requirements are, as we saw in the hierarchy, the master key in the master database, the certificate in the master database, which is called the server certificate from here on out, the database encryption key, which is inside the database itself. So you will use the database and put that database encryption key in. And that completes the hierarchy to allow you to alter the database and set encryption on for the user database. Now, once that encryption hierarchy is satisfied, you cannot break each one, any level below the database encryption key, or your database will cease to exist. Now, the benefit to you is that SQL Server in modern versions has protected your keys. So you can't go back and delete or drop the server certificate when encryption is on. Or even if it's off, if you have a database encryption key that is encrypted by the server certificate, you are not allowed to drop it. So you'll see that in demo. So because those keys are critical, and if you did turn them off and drop the database encryption key out of the database, you can drop those server certificates, which means you can't restore any backup that was made on that encrypted database without that certificate, public and private key. So protect your keys. Make sure you have backups for your databases, your keys, and all the other things that make your encryption hierarchy work. The advantages of TDE is that you don't have to change anything in the schema. There's nothing that has to change. It's all about the encryption at rest, which is the file or page level encryption that sits on the disk. That doesn't require any schema changes at all. The overhead is about 1% to 2%. And again, your mileage may vary. On some systems, it might be heavier if the data is bigger or blobby. That could hamper your throughput. But you can measure it yourself by looking at the database throughput with your database unencrypted, and then you can encrypt it in test and see how long it takes and see if that's acceptable. I have not had a problem. I've been running TDE since 2008, and each year it gets better with the size and the speed of which it encrypts. So I'm not too worried about that. The other advantage is you get secure backups by default. When you back up a database that's encrypted with TDE, it actually will encrypt your backup because the data does not go through buffer pool to get to the final resting place in the backup. So it goes straight from disk, which is encrypted, and it goes out to the backup file, which will be encrypted as well. That requires that server certificate to be on that box. Whichever one you want to restore it to, it has to have that server certificate. We'll show you that in demo. The other major advantage is the user has no idea that it even is encrypted. There's a flag on the database that says encrypted, but it does not. It's not visible to the user because if you select the data out, it goes from the disk into buffer pool, which gets decrypted, and the data in the buffer pool is decrypted. When it goes out to the client, it's decrypted. They have no idea that it went through the encryption cycle, coming out of the disk into buffer pool out to the client. So it's invisible. Hence the reason why it's called transparent. It's supposed to be transparent to the user. It's really to make sure your databases are secure on the disk. And then the advantage is also it is at rest. It is not encrypted throughout the whole system, so it takes less CPU. You decrypt it when it goes in the buffer pool, and from there it's just data, and you select and you query and you where clause and you sum and you do all those things. Those are things you get with TDE set up. Some of the disadvantages. Backup compression is no longer effective prior to SQL 2016. There is a CU and an SP that SQL 2016 enables the compression on SQL TDE databases. And it's pretty good. It actually is pretty close to the regular encryption. I think you might lose, instead of 5 to 1, it's maybe 4 to 1. So you'll see that when we demo it. I'll show you a little example. It's not a really great example, but it shows you that it doesn't get exactly what the normal compression does on an unencrypted database, but it's not terrible. It is not as versatile as cell column encryption, and the one before was Enterprise Edition. That is no longer the case in SQL 2019. SQL 2019, they've allowed TDE to be enabled on SQL Standard. That's where it stops. You can enable it on web or anything like that, but Enterprise Edition is required prior to SQL 2019. There's no indication that they are going to backfill that or retrofit that to SQL 2017. So just know 2019 allows you to encrypt databases in Standard and Enterprise prior to that. The other disadvantage is that when one database is encrypted, tempDB gets encrypted by default, and that gets encrypted at the same time or close after the user database gets encrypted. So you need to make sure you're aware that if you're a heavy tempDB user, that everything that goes in there, if it hits the disk, if it sits on disk, then it's going to be encrypted. Again, in memory, doesn't get encrypted. When it sits on the disk and it gets hit the disk, it's gonna take some hit. Database files and log files are encrypted, so you don't get any freebies there. When you decrypt all the databases off the server, tempDB will stay encrypted. until you restart the server, and the server creates a new tempdb that is unencrypted because it notices that there's no encrypted databases. So you do have to have a server restart to get tempdb unencrypted after you disable all the encryption on all the databases. Let's talk a little bit about what we're going to do in Key Vault. So TDE now has the ability to use Azure Key Vault as a store for keys. It stores, you create an asymmetric key because you're using an EKM, an enterprise key management, an extensible key management solution. The keys are stored not in the database, but externally. So these keys would reside in Azure Key Vault, and you would create one that's referencing that key in the Key Vault to create your asymmetric key in SQL so that you could encrypt your database with that. You have to have an installer for the SQL Server connector to get to Azure Key Vault. So you have to install that. That will I'll show you in the demo. There's a URL in the demo that shows you where to get that. And you just have to keep that up to date as you go if it requires it in Azure. It does require you to set up Azure. So if you don't have an Azure subscription, you need to get one if you're going to use Azure Key Vault. So that's important to know. It also requires internet access for those of you who have servers that do not have internet access from the SQL Server, which is pretty common in financial institutions and other places. You're going to need to make sure that you have a internet access for that, or you cannot use Key Vault because it's Azure. So you have to do that. Now that doesn't mean that you can't have an Azure pipe behind the scenes, an express route. If you have an express route, that is the same. You have to be able to access Azure. So if you have access to Azure without the internet, you still can do it as long as you have that. So if you don't have internet access, but you have that, then you can still use Key Vault. You need to access Key Vault every 8 hours, or at least you can't lose it for every 8 hours. If you lose it for more than 8 hours, you will lose your database. The key will go defunct and you will not be able to recover it. There is no way to recover it today. So in the event that your internet goes out or your connection to Azure goes out for longer than 8 hours, you might consider an alternative to create a new local key with a certificate and re-encrypt your database using those keys with a new database encryption key so that you don't lose your database because it's more than 8 hours. Make sure you test that. Drop your internet connection or take your internet connection away from your SQL Server. Make sure you have an alternative to make sure you stay alive, because otherwise your database will go inaccessible and you will not be able to get it back. Azure Key Vault setup. We're going to take you through really quick on this because I'm going to show you in Azure, in the Azure Management portal, how to do this. But the big deal is that it starts with an AD principle. So you will create an application registration, and in that app registration, you're going to create a secret. And that secret will give you a value, and you'll only see it once. You won't get to see it again. So you have to copy that out to make sure you don't lose it. And then you need an application ID as well. Once those two pieces are there, we'll store them out. I'll show you in the demo how to do that. Once you have that, then you can move on and create the Key Vault. The Key Vault itself will hold your key that will be used to create the asymmetric key. The Key Vault will require an access policy to the vault. In order to get access to the vault, you have to have an app principal, which you've created already in the first piece of the AD part. Once you have that access policy, you will give it the permissions that are listed below that say get, list, unwrap key, and wrap key permissions. That's all you need. You don't need all the other ones, and you want least privilege in this case for the connector to only be able to use what it needs to use. And then after you have that access policy assigned to the Key Vault, you will then create a key, and that key will have a name. It will generate the key, so you don't have to worry about how it's generated. You'll use RSA 2048, no dates, no activation date, no expiry date, and enabled. You enable it so that it is active and ready to go. You install the SQL Server connector. Once that takes place, you then configure the SQL Server to use the EKM provider. I have the URL in the demo to get that SQL Server provider or the connector, so you don't have to worry about that. In both of these slides, there is a setup link So when you get the slide deck, you'll be able to click on those links and get to the page that helps you set up the keys and the key vault and all that stuff. This is just the way to get there. And then we can configure SQL to use this EKM provider and create our asymmetric key. These are the slides that will help you with that, with the code. So if you just get the slides and don't get the demo, these have the code in there. First of all, you EKM provider enabled. That is a SP configure setting. And then you create the cryptographic provider and give it a name, and that is the path of the DLL. Then you create a credential, and it has a few others for you, but we create a credential in SQL to pass the secret of the application client ID and the app secret, the app client ID. Yeah, the application ID and the app client secret that we created in the beginning, and you'll see those in the demo. And then you're going to use the cryptographic provider of Azure Key Vault EKM, which is what we did here in creating the provider. So that will help you get that piece married up. After you have the credential, you will then alter your login. So I have a login that I'll be using, and I'll alter that login to add the credential that I just created so that it will be able to access Key Vault to create the things it needs to create, like the asymmetric key and things. Once that's done, we'll use the TDE login that we'll create. Once I've created the EKM sample key, that's what I named it, but it basically is creating an asymmetric key. You're going to reference the Key Vault key that we create in the Key Vault. And that key name will go in this statement with open existing as the creation disposition. Once we have that, then we will want to associate that asymmetric key to a SQL login instead of my login. So we'll drop the association after we create the login. We'll drop this credential from my login and we'll add it to the TD login. And then we'll create the database encryption key using the asymmetric key. And notice it says server asymmetric key. That means it's in the master database. And then we'll alter the database and set encryption on, and we're encrypted using Azure Key Vault. It's pretty slick. So let's go and demo the TDE things. We'll do traditional TDE, and then we'll do the encryption with the TDE on Azure Key Vault. Okay, here we are on my SQL server. We basically have a SQL demo 2 and a SQL demo. We'll connect to both of them so that we have access to both of those servers. And we'll go and clean up these databases here. And we'll make sure that we have it all cleaned up when we get done. So first of all, we're in demo 2. We're going to use master. We're going to set up TDE traditionally. It's really simple. We're going to use master. We're going to use demo TDE. And we're going to create a table in that database. And this table might already exist, so that's fine. Let's select from it and make sure that that table now has eight values in it. Now I'm going to back up this demo TDE database, and we're going to clear out this SQL backup folder so we don't have to worry about this guy here. Let's back up and delete all these guys. And now we're left with nothing. Okay, so now we're going to back up this compressed database that's unencrypted so far. So we'll back it up. And we'll init with compression so we can see the difference between the compression on the unencrypted and the compression on the encrypted database. And first of all, we're going to create our master key in master. So we're going to use master, and we're going to create the master key with by encryption by password. So this is our password. It's very long. You might want to store that password because if you ever need to open it to re-encrypt, you'll want to use this. You don't want to have to rekey it. So you'll want to keep this password as a very important key in a password vault. So let's create that. It looks like I already have that in here, so that's fine. Once I go here, then I'm going to look at my symmetric keys and see that I do already have a database master key in my server and as AES-256 as the encryption algorithm. So now I'm going to create my server certificate, and this is in the master again, so we don't have to worry about that. And actually, I believe I still have it here. Let's do, oh, you know what? I don't know if I can do drop certificate if it exists. I think it's only tables. But let's drop this certificate if it exists, and it doesn't. So let's create the server certificate here in master on demo 2. And all that is required is subject and an expiry date. Now the expiry date is not required. All that's actually required is the subject, but I put an expiry date of 2099. SQL Server doesn't honor the expiry date, so you don't have to worry about it expiring and your database becoming inaccessible. But the more important part is that I don't want it to warn me that my certificate's expired, and I'm pretty sure I'm going to be not here in 2099, so I'm pretty good. If I select out of certificates to see what my certificates are, I show that my backup certificate, and actually I'll drop this before we get done when we do the backup stuff, but here's my server certificate here to do the DEK for the database encryption key. I'm going to use demo TDE. I'm going to create my database encryption key and encrypt by server certificate my server cert, which is the server means master. And I'm going to use AES 128. I could use higher, but I'm going to use 128 today. And notice when I create the database encryption key and encrypt by the server certificate, and I haven't backed up that certificate, it will warn me, because if this database gets encrypted and I do not have the private key and something happens to my server, it becomes corrupt and the master database goes corrupt and I have to rebuild it, I lose that private key of my certificate if I don't have a backup, and that means I can't recover the backups. I can't recover the database. I can't recover anything because it relies on that certificate that is encrypting my database encryption key. And if I can't undo it, I'm in trouble. So we are going to back it up. So we'll go to master, we'll back up the server certificate to C backup, and then my server cert CER, that's the public key. I'll back up the private key to the PVK, and I'll encrypt that backup with my password. This does not encrypt the database by password, it just encrypts my private key backup. So we'll back that up, and you'll notice we have that here. Now we have both keys here. That will be important to see in a minute. And now I can look at my encryption and see that my database key has been backed up. So, or my server certificate has been backed up with the private key. So now once I have that in place, I can just basically set alter database demo TD, set encryption on. Now I'm going to run this just so you can see a status while it's running. I chose a decent sized database so that we can see that it is encrypting. So there's 2. We didn't get to catch it with a percentage, but the percent complete, if you have a large database, it will actually show percent complete 50, 60, 70, and then it will go to 0. Percent complete 0 is just like fill factor 0. It equals 100. But 2, if we scroll up here in my demo script, it shows that 2 equals encryption in progress. So it is encrypted here. TempDB is encrypted, and it's got a 3, which means encrypted, and 0% complete. And it's using AES 256, where I chose AES 128. If I ran this query again, I would see that my database is now encrypted with 3 and 0. So I am fully encrypted on my database now. And I can still select out my create date, which is the local time. And if I use my encrypt database encryption keys instead of sys databases, it will come out and show me that it is in GMT. So that's interesting. All right, so now we use master. We're going to back up the database encrypted with compression. So let's back that up. And you'll see that even though I encrypted the database, that the sizes are pretty close, 47 meg to 46 meg. So the encrypted one's a little bit bigger, but not terrible. It's not a terrible size backup, so that's pretty good. So I lose a little because it's encrypted, but it's not a terrible thing. All right, now we're going to switch to our second instance to show you how to recover from our database backup. We will go in here and we will do some cleanup here. So we can see that we are on the same version. This is RTM. I guess it could be RTM CU8. I don't think I installed a CU8 on the other machine, but we do have the version of 2019 because we can't restore otherwise. If I go in here and restore file list only, it will come back and tell me that it cannot find the server certificate of this thumbprint. And I have to have that in order to decrypt it. So what I'm going to do is I'm going to reestablish the hierarchy on SQL demo, just like we talked about. So we're going to use master. I'm going to create a different master key. We're using a different password because it's on a different instance. I would protect this key as well, so I could open up this certificate or this master key. And now I'm going to create a I have to have this certificate over on this local. I could do it on a share, but I have to have it on this local box so that I can. And let's just do this for all. So I'm copying these over. When I copy them over, I will lose permissions that are set on the current one. That will allow me to restore it. If I didn't, if I was trying to go from the same folder, I would have to go grant permissions to the new SQL Server account to do this. Now I'm running under the same SQL Server account, so it shouldn't matter in this case, so it should be okay. But I'm going to create my server certificate in SQL demo on the master database, and it's going to create. And then I'm going to see that I have my encrypted by master key. I'm now showing I have not backed up my private, because that's the way it works when I've restored. Even though I created it from a backup, I still have to back it up again in order to get that to not warn me. So now I can do a restore file list only. Oh, nope, I have to copy this over. So notice the SQL backup here. I have to copy this encrypted backup over here to the other one because I already had one over there already. Apologize for that. But you notice that the certificate wasn't the same, so it refused to do a restore file list only. So now I do a restore file list only and I get my database backup. So now I'm going to restore my backup. I'm going to use and select from demo TD. And there's my data. So pretty cool. If I tried to drop the master key, it would not let me. If I tried to drop the certificate, it would not let me because I have hooks into my database. And even if I set the database alter encryption off, I still couldn't delete the certificate until I either drop the database or until I drop the database encryption key. So that's TD. Pretty simple, not terrible, but that's how it works. Now let's go into the TD Key Vault. It's a little more involved in this scenario, and we're going to do it on demo 2. So first of all, we're going to reconfigure the engine to use the EKM provider. We're going to enable the EKM provider because we're going to use Key Vault. So we use master and do the SP configure things. We change from 0 to 1. And now I have already downloaded this. This is the link to download the SQL Server connector for Microsoft Azure Key Vault. I've installed it, and this is where the thing is. Now, we're going to pause here, and we're going to go create everything in Azure before we create all these things. So let's go back our Azure portal here, and we will go into our resource group, and we're going to add, we're going to go to Azure Active Directory first. In Azure Active Directory, you'll see that we go into app registrations, and we do not have any app registration, so we're going to do a new registration here. New registration, we're going to call it DBA Duck app. So here's our app, and we're going to allow accounts in the organization directory only, and we're going to register. Now, when we register this guy, it comes up, and it's pretty fast in creation of this registration. But then we have to go into certificates and secrets, and we have to create a client secret here. So new client secret here, we name it DBA client secret. We click never because we don't want it to expire. We click add, and it will add this client secret, and this is the value we need to get. So let's copy that value, and we'll put it into here, client secret. And then we'll go out here. And then we click on overview, and there will be an application, a client ID here. So we'll copy this to clipboard, and we'll copy this up here. Now the key here is I need to take out the dashes. It's just a GUID, but I need to take out the dashes in order to use it in this connector. Why it needs that, I don't know, but I guess the dashes throw it for a loop. So we'll save those off. We'll use those in a moment. And now we've got the secrets. Now we're going to go back, and we're going to create us a Key Vault. So let's go into here. And we're going to add, and we're going to just say Azure Key Vault. And I think it moved on me. That's really weird. Add Azure Key Vault. And in the marketplace, there will be an Azure Key Vault, hopefully close to the top, which it should be second. Click on Key Vault, click Create, and it will start walking us through the way to create this thing. So I enter the name of the Key Vault. We're just going to call it DBA Duck Key Vault. I'm going to leave it in the E. Okay. Oh, because I already, yeah. It has previously soft deleted. So we're just going to do 2. Key Vault 2. And now we have to add an access policy to this guy. And here's our add access policy. So we're going to add access policy for the SQL Server connector as a template. And notice it only has the 4 get, list, unwrap, and wrap key. So that's important. We don't need any other permissions, least privilege here. And we click on the none selected to add the app. So we're going to do DBA Duck app. And sure enough, there it is. We select it, it comes over here, and we add that policy. And then we save our thing by doing review and create. So we review and create. It creates our, and notice the soft delete is enabled because that's the default now. And create. It'll create my vault. It doesn't take a ton of time, but it does take a little bit. And the vault has to be created and ready with the key in order for us to do anything else in SQL. So we'll be waiting here for just a moment. Now we're in our Azure Key Vault, and it's called DBA Key Vault 2. We're going to create a key. So we're going to Keys, and there's no keys. So we create or generate import, and we have generate. We're going to name it DBA Duck Key RSA 2048. We're not going to set an activation date. We're not going to set an expiration date, and we're going to enable that key. So we create it, and it's pretty fast to create that key. It's done. Now we have everything we need to go and do our Key Vault. Now, the first thing we're going to do is we're going to create the cryptographic provider called Azure Key Vault EKM from the Key Vault DLL, which is the full path here. The path has to be less than 256 characters. So if it's more than 256, then it will throw an error. If you want, this is the default. If you want to move it somewhere else, I mean, this is a pretty wordy directory. If you wanted to do something different, you could actually change the directory it installs in and then create it that way. So let's create the Key Vault cryptographic provider, which is pretty fast. There is a problem that we may have to go back and create a key in the registry. We'll see if this works. It's supposed to be fixed, but we'll see if it works. If not, we'll go back and create it. So here's our DBA Duck Key Vault. We'll have to put a 2 on the end because I did soft delete one, and it does not like you to duplicate that. So we're going to put the client app, the application ID first. So we're going to take this whole thing out. And as you saw in the demo or in the slide, we have to put the application ID first and the client secret second, just butt up against it. So come back here right after that, just like that. And then we're going to create our credential. Now, this is the important part. If I execute this, it creates it pretty fast. And now I'm going to add that credential to my login. So I'm adding the credential to my login so I can create the next piece. Now, what I've noticed is that doing this piece right here actually throws an error. So we called it dba.key, as what I remember, dba.key. And so if I create this or try to create this now, I'm going to try to create the asymmetric key, and it may come back with an error. This 2058 error is a really naughty error, but it is known. It's the bug. So I have to go into the registry, and in the registry, I'm going to go to HKey local machines, software Microsoft, and create a new key. And the new key is called SQL Server Cryptographic Provider. And this SQL cryptographic provider, I have to do permissions and give permissions to the SQL Server service account. And give it full control on that key. Now, if I go back out after creating that, I can go like this. And now if I create it, it did work. So sometimes you have to take this statement and go into a new window to allow your credentials to pick up, or your login to pick up that new credential. In this case, I did not have to, so that worked out great. Once I have this asymmetric key created, then I create a new login, a SQL login for this asymmetric key to associate it to. So I create that. And then I alter my login here and drop the credential off of my login. And then I add it to the TDE login. And now I'm going to create my database test TDE. It doesn't exist. So we're going to create the test database TDE. We're going to create the database encryption key when we go, let me put this in here, use test TDE, because you do have to be in the database. So let's do this, use test TDE. If we create our database encryption key, we create it by server asymmetric key. So let's do that. And now it's going to reach out to the asymmetric key, and then I'm going to alter database and set test TDE on, and it is encrypted. So now I have an encrypted database that is talking to Azure Key Vault, and it's all in place. So there's a few pieces to set up. Not terrible, but you do have to set up some things. So let's go back to our slides. That was a fun ride around TDE. Now we're going to talk about cell encryption. This one does not have a demo. It would take too long to do a demo on this one and all the other ones. So we're going to omit this demo. If you want to, you can reach out to me and I'll send you a demo script you can play with. But basically it's about creating a symmetric key or a certificate to encrypt your data. Basically, when using cell encryption, you can do a few things. You can use a certificate because it is got a private key and a public key. You can use an asymmetric key, which is 2 keys, or you can use a symmetric key, which is 1 key, to encrypt your data in your cell. The big deal about this guy is that it needs the hierarchy still in place. So you still have to have a database master key in master in order to get this to work. But you can establish the encryption hierarchy from the master, and then you can open the keys without having to use a password to open them. The cell, although the TDE doesn't have any schema changes, you do have to change schema on this one if you want to do cell encryption by using these keys, any one of these keys. You have to change it to a var binary and at least 128, I believe, to get this to work. And it cannot be indexed, and you cannot search it. So that's one of the drawbacks of cell encryption, is you get encrypted data, but that's not searchable or anything like that, like always encrypted will be, which we'll talk about in a minute. The data is encrypted in the buffer pool though. So when you pull that data out and you pull the data into buffer pool, it is encrypted, and it comes unencrypted when you select it back to the client. So that's one of the things about cell encryption that's important to know. Symmetric and asymmetric keys. You can use a symmetric key, but don't use the RC4 algorithms. They've been cracked, so don't do that. Your data will be vulnerable. You can use a triple DES 3 key, which is a 192-bit key, or you can use an algorithm of triple DES, which is a 128-bit key. So just know that that's your options if you use symmetric keys. The asymmetric keys, on the other hand, they're 2 keys basically in one, and the ownership is really important. They have to be owned by Windows logins, SQL Server logins, or application roles. They cannot be owned by groups, and they can't be owned by regular database roles. So you can't do that. But once you create them in there, you can use the asymmetric key to encrypt data. Now, the drawback of using an asymmetric key is it's 2 keys, so it takes longer to encrypt. It's stronger, but it takes longer. We'll talk about that in a second. So the key pair and encrypted by master key, the key pair, and it's a key pair, and it's encrypted by master key, password, or EKM provider. You can have an EKM, just like we did the asymmetric key in Key Vault. You can do that too for this encryption. You don't have to use it the other way. It can be RSA 512, 1024, or 2048, which is the bigger the bits, the longer it will take to encrypt. So if you have high transactions, high throughput, they're going to take a hit on the speed as you go up in key length. Notes on encrypting data. The most important thing to know is that performance is important when you have high transactions. So you will want to use symmetric keys first. They're the fastest. Then certificates is second. And then asymmetric keys is third. So depending on what you do, the big thing about the symmetric keys in the use of certificates instead is that symmetric keys can be used and opened using open the symmetric key with the encryption hierarchy in place as long as you use them in stored procedures. You cannot open a symmetric key in a function. So if you want to use functions to decrypt these things instead of using open symmetric key and giving permissions on that, you have to use certificates. And certificates are just a little bit slower than symmetric keys, but you can use them in functions. So it's kind of one of those things. An EKM, if you want to do an extensible key management solution, they can hold the symmetric or asymmetric keys outside of SQL Server, so you can have key separation, not store them in the database. And then just for note, the service master key and all database master keys and even the database encryption key are symmetric keys. So they are the fastest they have in SQL Server. Let's dovetail into always encrypted. We're going to talk about the column master key, the column encryption key, and the certificates and things that we have to have for always encrypted. The big thing about always encrypted, I think, was one of the things about role separation. So it's a big deal when the DBA, one of the big things that came up is, can the DBA query the data and see it if it's sensitive? And the DBAs require sysadmin access, so it's really not that common to have a DBA that doesn't have access to SQL in a big way. And so if the data is encrypted and it's got symmetric keys and stuff, they're going to be able to see symmetric keys, and so they can get the data. So this is one of the ways that you can keep the DBA from seeing the encrypted data. If you have the certificate that gets created not on the machine that the DBA uses to query the data, you won't be able to decrypt it. There's no way. So the DBA will not have access to the encrypted data, and it will just be a blob. There's no way to decrypt it without the key. You can use local or centralized key stores. You can even use Azure Key Vault for this if you want. But again, you just make sure that you have protection on the side of the certificates. The certificates don't honor the authority chain or the expiry date, so the expiration date doesn't matter. It will warn you still that the thing's expired, but it won't stop the data from being decrypted. So my suggestion is to either create a self-signed that's just like we did with TD and make it in the future, or use a normal VeriSign or whatever DigiCert, whoever you use your certificates through, get your certificate and keep it up to date and use it that way. And that way you have certificate authority chain and expiry date, and you just keep rotating those in and renewing those certificates, so it's all good. It is not a bad idea to rotate, but again, when you rotate the keys, it has to encrypt and decrypt, so just be aware of that. It is a standard certificate, so it's not special. It's not a specific one. The only thing you have to worry about is that you have the private key, and they recommend greater than 2048 or equal to 2048 bits of encryption, and the key must be created for key exchange in order to be used with always encrypted. If it has that permission on that certificate, then you're good to go. The other last piece is that you must have that certificate on the client that is going to decrypt, because the difference with always encrypted is that the encryption doesn't happen at SQL Server. It doesn't happen on the SQL Server at all. In fact, the certificate is not even on the SQL Server. So the SQL Server itself can't even differentiate the data. All it can do is use what is there. The client actually decrypts, so the certificate would have to be on the client. Always encrypted requirements, you have to have the certificate created on the client. You have a column master key and a column encryption key. String columns, if you're going to use them for searching, you must have a binary to collation, as well as deterministic encryption, which means that the same value will be the same value encrypted as another value of the same. So if I encrypted an A, it would contain the same encrypted value if it was deterministic, and that way you can index and you can search on those things. So that's kind of cool. You can do a randomized encryption, but you can't index it or search them. So randomized encryption is stronger. The same value would be encrypted differently, as far as the value would be different because it's randomized, and the application would handle all that for you, the driver. The algorithm, there's only one, so you don't have to worry about that. You just have to put that one big one, and the GUI will handle that all for you in Management Studio. Temporal tables cannot have always encrypted columns. So just know that if you're going to do temporal tables, you can't do always encrypted in those tables because they have no mechanism to translate that data out because it's on SQL Server. It isn't going through the client. If it's going through the client, you're good, but this is not. Triggers are only partially supported. You can use it on an encrypted table or a table that has always encrypted columns, but you cannot use the encrypted columns from the inserted and deleted tables. It's forbidden because it can't decrypt them anyway, so you won't be able to use them. That doesn't really help you. In-memory OLTP doesn't support encrypted columns, and foreign keys must match the encryption type. So if you have one table that has a primary key and one table that has a foreign key, that foreign key has to match that primary key's encryption type, deterministic or randomized, to be able to make that work. And then the last piece is the column encryption setting in .NET Framework 4.6 and above, even .NET Core. There's a column encryption setting equals enabled that goes in the connection string that makes that possible. I'll show you that. And then there's more that you have to worry about, but there's a very good reference with examples of error messages from Aaron Bertrand that will let you see some of the things that happen. It was a T-SQL Tuesday type post. And that's it for the slides for Always Encrypted. Let's go ahead and go into the Always Encrypted demo and show you how that works. Okay, here we are. We do not have we're going to create a database for this. So we're going to create a demo DB to allow us to do a Always Encrypted scenario. So we're going to create that database now on demo 2. We're going to use that database and create us a table. This table is not going to have anything special in it, except we're going to encrypt this SSN column. And we have a primary key on our little ID event. And let's create this guy first. Make sure we got it all good. So we've created that table in the DemoDB database. And notice it's empty. So the empty part here, there's nothing there. And we're going to go ahead and show you a couple of ways to encrypt this data. So let's refresh our container here and go into DemoDB. There's a tables, and this is the way we're going to encrypt it, but I want to show you a couple other ways, or another way. So I can do test table, right click, and do encrypt columns. I'm using 18 version of SSMS, so the encrypt columns is right off the right click. Or I can go into security in the database, and there's a always encrypted keys with your master and encryption, your column master and column encryption keys. I can create each one of these separately if I want to and reference each other. So this would be my column master key I'd reference if I created them separately. But this piece on the table does them all for you at the same time. So I'm going to say encrypt columns here. It's going to pop up the dialog box and it's going to let me choose the SSN column here. And I'm going to choose deterministic so I can show you how that works. I'm going to click next. And I'm going to go ahead and use auto-generate column master key. And I'm going to use the Windows certificate store. I could use Azure Key Vault, but I'm not going to. And then it stores the master key source in the current user. If I click next, it just says proceed to finish. And now it will go ahead and start the creation of the column master key and the column encryption keys. So it already did that. Now it's performing the encryption options. Now in our case, we don't have any data. So it's not going to be that hard to do. In the case where you have data, it has to do more work to get that to work, but I'm creating it without anything. Now I'm in my connection here to SQL Demo 2, and I'm in DemoDB, and I'm going to try to insert data into that table. And it's going to come back and tell me that I have a clash with a incompatible with varchar 8000 and encrypted with type of deterministic. So I can't do that really easily. So I'm going to try to fake it out and do this declare. So it's a parameter, because parameters, SQL likes parameters, but it's still going to throw an error and tell me I have a problem. So one thing we want to do here is we're going to make our connection available to use the encryption. So we're going to go to SQL Demo 2. We're going to do options, click additional connection parameters, and there's nothing in there. We're going to add our column encryption setting equals enabled in this guy. And we're going to say connect. Now we're going to go back into our DemoDB and we're going to insert in here, and it's going to say it doesn't like me still because I'm trying to insert a value directly. Now Management Studio has this feature that lets us parameterize it and lets us use parameterization, and it will take this parameter and it will encrypt it and then insert it in the values. So again, the client does this. SQL Server does not. So the client took this, parameterized it, stuffed it in here, and now if I select it from test table, you would see that I have indeed a decrypted value. Now I'm going to do it again and add it in with value 2 and change the name, but put the same social security number in here. And I'm going to show you for a reason. So now I go up here and I select from the database here, and you'll see that they're decrypted. If I went and took this connection and changed it to take that setting out, so let's go back into here, take this setting out to column encryption setting enabled, click connect, and now selected from it, now you'll see a blob value. But notice they look the same. Every character is the same. And if I expand this out all the way to the end, you'll see that they are indeed the same. They end in B35398. So this is deterministic encryption. And it lets me search and create an index on it. So always encrypted is not hard. But again, what I would have to do if I wanted another client or the web server or an API server, I'd have to export the client certificate from here, from this machine. I'd have to export it out to a file and then import it back into that machine's certificate store and then use it because I've already married it up with the column encryption certificates here. So I'm good to go with that. But there is a few things of plumbing you'd have to do after that. So just know that it's a pretty slick little deal. Okay, the last section we're going to do is the backup encryption. So the backup encryption deals with an asymmetric key or a certificate. Let's talk about how that works. Backup encryption is SQL 2014 and above. So in SQL 2014, they gave us the ability to create a certificate or an asymmetric key and use it to back up with encryption. For all those unencrypted databases, we can now encrypt the backups. And the compression is completely good. It actually compresses it before it encrypts it. So because it's unencrypted, it doesn't have the encrypted stream coming out of the data file. So it does have full compression capability, and then it encrypts the compressed stream. It can be a certificate or asymmetric key, but if you want to use an asymmetric key for really strong encryption, it has to be an EKM. So just like Key Vault, you have to have the asymmetric key in the Key Vault or in another EKM HSM solution that has the key somewhere else. It won't store it in the SQL. Or you can just use a certificate. And my recommendation is don't use the same certificate you would use for a TDE database. In fact, the recommendation is to have a single certificate for each database and have separate certificates for each database so that you can have separation of concerns with that. So in this case, you would create a certificate or a asymmetric key in an EKM. You can encrypt with AES 128, 192, 256, or triple DES. The other requirement is that you must do a new media set. You cannot add it to an existing one. So when you create it, you have to use the language in the backup statement to do a new media set. And that way it can back up to encryption. If you are the unfortunate ones to want to put it in the same file, you cannot do that. So just know. If the person is not a sysadmin, then you're going to have to do permissions for that user to back it up. It has to have DB backup operator membership in the SQL Server. And then you're going to have view definition on the server certificate in MasterDB, because that's where you'd create this certificate is in master, because it is a server certificate used to back up. You couldn't create a certificate in the user database and back it up with that. That wouldn't make any sense because you'd have to unencrypt the database backup to get the certificate, which you kind of inception type thing. So they have to have view definition on the certificate in MasterDB if they're not a sysadmin. Typically, you're going to back up with jobs, and the jobs are going to use the SQL Server user, and you're kind of good there because the agent has sysadmin privileges on that box. So they're sysadmin, so they can get to it. So don't I mean, if you want to make hokey pokey, then you can do that. But in this case, I would just say that the sysadmins would do the backups. And then let's go show you backup encryption to cap this thing off. Okay, so here we are with our backup. And right now we are on SQL Demo 2, and we're going to see if we have our master key, because again, this is part of importance of having the encryption hierarchy in place. If I didn't have the encryption hierarchy set up for my TDE, then I would need to create my master key again for this. I'd have to create a master key in the master database because the encryption hierarchy has to be in place. But it is there, database master key there, AES 256, we're good. Now we're going to create our backup certificate. Now I know for a fact that my certificate is already created, so I'm going to drop the current one. And we're going to create one called My Backup Cert, and we're going to name it My Backup Cert in subject, and again 2099-0101, just so that I don't have to worry about expiry dates. So let's create that guy. And because I created it and we have a master key, everything was encrypted. If I were to look at symmetric keys, or certificates, I mean, you would see that I have my backup certificate and it is encrypted by the master key, MK, but then it says encrypted by master key, so we're good to go. So now, when we have that, I'm allowed to back up my database. We're going to back up it to DBA2, and with format, with a init, and my media name, new media name, and new name of my backup. But I have to have a new media name in order for this to work. So that's where you don't get to bypass this. I'm going to compress it, and I'm going to do encryption by algorithm of AES 256 with the server certificate of my backup cert. And now I get to back up my database. And it backed it up, and it's all good. And I look and I get my backup, and I see DBA backup 2, and it's really small, but it compressed it as well as encrypted. I would have to have this certificate. So say I restore file list only of, let's do this. Let's put this on demo 2, just so you can see what happens with this. The same thing with TDE. Restore file list only from disk equals C SQL backup DBA2 dot back. Let's copy that back file over. Back, copy, paste it over here into the other server so we can reference it. And let's see what it tells me when I try to restore file list only on SQL Demo. It comes up and says the same thing TDE did. I don't have that certificate. You must restore the certificate or else I can't restore. So backups are protected as well. Everything's happy. But that's kind of the way it works with the backup with certificates. And that concludes our session on SQL Server Encryption Unplugged. We've talked about a lot of things. We've talked about TDE traditional and TDE with Key Vault. We've talked about column encryption and always encrypted with all the fun things there. And we've also talked about SQL backups with encryption using certificates. And now we will go into questions. Thank you very much for attending, and have a great day.